Hello all, welcome to this lecture where we'll understand what is fit and how training of the model is important to fit the model well and what is a good fit and what are the issues over here like overfitting and underfitting of a model and how we can overcome overfitting and underfitting in this case. So let's see that. What is fit? In machine learning, fit refers to how well a model has learned from the training data. Firstly, what is training the model? So during training, the model looks at data and tries to learn the underlying patterns. And the goal is for the model to fit those patterns well enough that it can make accurate predictions on new data. So that is the reason we train the model, so that it can give accurate predictions on new data when we inference it. And what is a good fit? A good fit means the model has learned the important patterns in the training data without being overly specific. It can generalize well to new and unseen data. But there could be few issues as well while training the data like overfitting and underfitting. Let's understand them. Firstly, overfitting. This happens when the model fits the training data too closely, learning even the noise or random fluctuations. An overfitted model may perform very well on training data, but poorly on new data because it's too specific to training methods. And when it comes to underfitting, this occurs when the model doesn't learn enough from training data, missing important patterns. An underfitted model performs poorly both on training data and new data because it is too simplistic. So that is the issue with underfitting. Let's see this with an example. Firstly, typically when you train a model and whatever data you have to train the model, you use 80% of the data for training model. And then you use 10% of the data for model evaluation so that you check how the model is performing with that 10% of the data. And remaining 10% is used for the final test before deploying the model to production. That is how typical model training process goes. Suppose you are training a model to classify emails as spam or not spam using a set of features like word frequency or sender information. Now, overfitting happens when you are creating a machine learning model that perfectly classifies the training data. The model might have learned very specific rules such as exact word sequences or sender names that appear in the training data but are not relevant to the most real-world scenarios. And because of this, the model has a very low error on training data but performs poorly on new emails because it has memorized specific examples rather than learning the general concept of what makes an email spam. And when you visualize this in a scatter plot of data points with complex curve that zigzags through every point, trying to perfectly match the data, this curve fits the training data very well but fails to predict the trend when new points are added. Now let's consider the same example for underfitting of email, whether it is a spam or not spam. So in this example, you are trying to train a linear model like logistic regression to classify emails as spam or not spam. And when you try to visualize this in a graph, you get a scatter plot of data points with a straight line drawn through them, where the line fails to match the general trend of the data points. The line is too simple and does not capture the relationship between the variables. Let's understand the key differences between overfitting and underfitting. When it comes to model complexity, overfitting is highly complex. It often has too many parameters or overly flexible models. For example, deep trees with many layers or high degree of polynomials. And when it comes to underfitting, it has very low complexity, usually with too few parameters or overly simplistic models like linear models or non-linear problems. And when it comes to training error, in overfitting, the training error is very low, almost close to zero. And for underfitting, the training error is very, very high. And testing error, when we are testing with some real-life scenario, in overfitting, the error is very, very high. Same is the case with underfitting, the test error is very, very high. So if you see the error differences between overfitting and underfitting, both of them have high error when it comes to test data. Whereas in training, overfitting has low error because it has overly fitted the training data. And when it comes to performance on new data, overfitting is very poor because it knows only to work well with trained data. And when it comes to underfitting, it is again poor because it is poor on test as well as new data. And let's see behavior on plots. When it comes to overfitting, it fits the training data points very closely, including the noise. And for underfitting, it fails to fit the training data points adequately, often misses key trends. And variance, overfitting has high variance. Model predictions vary greatly with small changes in input data. And underfitting has low variance predictions are stable but are biased. And lastly, when it comes to bias, overfitting has low bias because it is overly flexible model that learns noise as well. And underfitting, it has high bias, oversimplified model that misses key patterns as well. Now let's see how to address overfitting problem. First option is simplify the model. Use less number of features by doing feature selection or dimensionality reduction techniques. And secondly, reduce the complexity of the model. Example, decrease the depth of decision trees or reduce the number of layers or nodes in neural network. Next, increase training data. Gather more training data to help the model generalize better by exposing it to more examples. And you may also use data augmentation techniques to artificially increase the size of the dataset, especially useful in domains like image processing. And you may do early stopping. During training, monitor the performance on a validation set and stop the training process when performance on the validation set begins to degrade, even if performance on the training set continues to improve. Now let's see how to address underfitting. First option is increase model complexity. Yes, this is opposite of what we did in overfitting. Over here, use more complex models. Example, switch from linear regression to polynomial regression, use deeper trees, or increase the layers or nodes in neural networks. Next, improve feature engineering. Over here, you can add new, more informative features or transform existing features to better capture the underlying patterns. And you may use domain knowledge to create features that the model might have missed with the original feature set. And you may increase training time. Train the model for more epochs or iterations. Epoch is similar to iteration, particularly for complex models like neural networks to allow it to learn more from the training data. So, by identifying whether a model is overfitting or underfitting, you can apply the appropriate strategies to improve its performance and ensure it generalizes well on new data. So that's it in this lecture. I hope you like it. Thank you.